All right. Arunan, quick roll call.
Yep. Yep. Yep.
Okay. All right. So now what we will do, we will talk to the server, right? So we will process the data in the server. Okay. So here is one more thing. Let me ask you this before we even get in there. Okay. Um, at this point of time, right? So if you take the functionality, these two are completely independent, right? The spinner is independent of buck tracker, the buck tracker is independent of spinner, right? The state and behavior of one doesn't influence the other. The state and behavior of one doesn't influence the other, but I want it to influence, right? I want it to influence, I want to relate them together, connect them together. So how do I do that? Let us take a very basic what do you call, not a very real time or meaningful requirement. Okay, so the requirement is the bucks, right? Whatever bucks that we are displaying, it has to be based on the value of the spinner. The bucks that we display here should be based on the value in the spinner. What do you mean by value in the spinner? If the spinner value is odd number, right? Odd. If the value is odd, then we have to display the bucks with odd ID, ID with odd number. Okay. So if the spinner value is even, we have to display all the bucks with even ID. If the spinner value is odd number, then the bucks has to display only the bucks with odd ID. If the spinner value is even number, then we have to display all the bucks with even ID. Now look at the code and tell me where we have to make the changes in order to incorporate this change request. You all understood the problem? The bucks that we display should be based on the spinner value. If the spinner value is even, then display all the bucks with even ID. If the spinner value is odd, display all the bucks with odd ID. Where will we write the logic for this? So you need to find a place in the code where you have access to both the spinner data and as well as the bucks data. What is that one place where you have access to both spinner data and as well as bucks data? If you take the spinner reducer, it will get only the spinner data. If you take the bucks reducer, it will get only the bucks data, right? Now here we want to have access to both spinner data and as well as bucks data. What is that one place where we have access to both spinner data and as well as bucks data? In the connect method, right? Very good. So especially it is in the map state to props, right? It is in the map state to props. So map state to props is one area in your application where you have access to the whole state, right? Where you have access to the whole state. Okay, and If you want to have access to the whole state, if you want to have access to the whole state, the complete application state for presentation purpose, then the place where to look for is the map state to props. Okay, so here I'll have bugs data and as well as the spinner data. Get the spinner data also, right? Extract the spinner data also, and then here we will say bugs is bugs dot filter, take one bug at a time and check if the bug.id mod 2 is equal to the spinner data mod 2. That's all, right? So I'm grabbing both the bugs data and as well as spinner data and then filter the bugs and send it to the component. Now save this, go to the browser, and here let us add the bugs. I'll say bug 1, right? This is bug with the id 1, right? Bug 1, add new. I have clicked the button, it is not displaying because 0 is considered as even. Here the id is 1, right? It is mismatching. But you say bug 2, add new, it is displaying. Bug 3, add new, it is not displaying. Bug 4, add new, it is displaying. Bug 5, add new, it is not displaying. And bug 6, add new, it is displaying. Now you increment the value in the counter, so delta is 1, and you click up. Now it is displaying 1, 3 and 5, up to 4 and 6, up 1, 3 and 5, up to 4 and 6, right? So now we are able to relate the data between these two. So if you want to have access to the whole state when for presentation purpose, if you want to have access to the whole state for presentation purposes, then you have to look at the map state to props. You have to look at the map state to props. If you want, make a note of it. If you want to have access to the whole store state for presentation purpose, for display purposes, then the place where you have to look at is map state to props. Okay, now here this filter is applied by default at all times. This filter is applied by default at all times. I don't want this to be applied at all times. I want to have a checkbox, something somewhere in the application, right? Be it in spinner or bug tracker, it doesn't matter. Somewhere in the application, I want to have a checkbox, and if the checkbox is checked, this filter need to be applied. If the checkbox is unchecked, this filter should not be applied, right? So we are displaying odd bugs and even bugs based on the spinner value, right? So as of now, it is this behavior exists at all times. We don't want this behavior to exist at all times. This behavior should exist only based on user interaction. So we can have a checkbox. Where can we have it? Anywhere in the application we can have a checkbox, and it can be in bug tracker, it can be in spinner, wherever. Okay, so for now I'm going to have it in the bug tracker, right? I'm going to have it in the bug tracker. So in the bug tracker, let's say after this label apply filter, and then I will have a input type equal to checkbox. Input type equal to checkbox. So go to the UI, you have the apply filter. If this checkbox is checked, then you have to relate these two. If the checkbox is unchecked, then you have to display the bugs, the existing bugs as it is. You should not filter them based on the spinner value. Now, where will I implement this logic? In the bug tracker reducer, okay. Actions, okay. Which action? So take a few minutes, implement it. Take a few minutes, implement it. The question is, so if you look at the UI, by default, the bugs will be filtered based on the spinner, right? So by default, the bugs will be filtered based on the spinner. So if you add a bug now, bug 1, it will not show up. It will not show up. I have added, but it will not show up because the spinner value is even, whereas the bug ID is odd. And then you say bug 2, add new, it shows up, and bug 3, it will not show up, and bug 4, add new, it shows up, right? So this in our existing implementation, this relationship is already established between the spinner and the bug tracker. But I don't want this relationship to exist at all times. I want this relationship to exist on demand. So I'm going to have a checkbox, and if the checkbox is checked, then establish the relationship between these two. If the checkbox is unchecked, then don't establish the relationship between these two. Thank you. Remember, the checkbox can be anywhere. That checkbox can be in spinner, the checkbox can be in bug tracker, it can be outside also. The checkbox can be anywhere in the application. Anyone? Okay, so looks like, are you attempting it? Anyone? Simple. See, remember that diagram, right? Remember this diagram at all times. So you have the UI, you have the action dispatcher, and you have the reducer function, and here is a store, and here is the render function, right? So when the user interacts with the application, the action is dispatched, and the store receives it, and the reducer processes it, and it comes back, and then it gets rendered, and finally the application is rendered, right? So remember this diagram at all times. So here we have a checkbox. We have a checkbox. When the user clicks the checkbox, right, what you display must change in the UI. When the user clicks the checkbox, what you display must change in the UI. When can you do that? Only when the application is rendered again. Only when the application is rendered again. When the application will render, so if you want to change how it is rendered, so this data, this checkbox data, whether you have checked it or not, has to reach you in the next time when the application is rendered. So how can it reach me the next time when the application is rendered? It has to be in the store. How can it reach the store? It has to go through the reducer, right? So what need to happen? When you when you when you click the checkbox, when you click the checkbox, you have to dispatch an action that should result in a state change through the reducer, and then that will result in a re-render. And when it is re-rendered, you can decide what you want to display. So for this simple checkbox, you need an action, you need a reducer, and then you have to it will come through the map state to props, and then you can decide what need to display. Make sense? Right? So should it be in the same reducer, or can it be in a different reducer? Your choice. You can have it in any of the existing reducers, or you can keep it in a different reducer also. It doesn't matter. Okay. Now my only concern would be, if I keep it in an existing reducer, if I keep that in an existing reducer, right? If you take the reducers, Bux reducer, if I keep this in an existing reducer, my current state will change, right? You have to change this from an array into an object that will have the bugs, and as well as the checkbox status, whether the checkbox is checked or not, right? So the current state will change. So I don't have to change this. What I can do, I can have one more reducer. So create a new file, call it as bugs filter reducer .js, and then export function bugs filter reducer, and then current state is by default false. Current state is by default false, and an action. Okay, and I'll simply say if the return current state, and here we will simply set if action dot apply filter, then return action dot apply filter. Okay, apply filter will be the true or false, right? So this will be the true or false. Type equal to filter, apply filter, true or false. Okay, so this will be our reducer, bugs filter reducer, and in the main index.js we will export this. So Bux filter reducer, and here let us import it. Import Bux filter reducer from dot slash Bux filter reducer and import this. So Bux filter reducer. Okay, we have this. And now when the store is created, we also need to include the Bux filter reducer as well. So in the store index.js, get all the reducers, and then should filter is reducers dot Bux filter reducer. Reducers dot Bux filter reducer should filter. Okay, very good. Now from the checkbox, we need to have an action, right? So in the actions, let me create a new file, call it as apply filter dot js, and we'll have it as an export function. So export function apply filter, and this will take right, should apply filter and return an object where type is buck filter, right? And apply filter is should apply filter. Apply filter is should apply filter. So I think in the reducer, buck filter reducer, we need to check if action dot type is equal to bug underscore filter, then return action dot apply filter. Okay, very good. So apply filter is done. So this is our action. Okay, now this has to go through the index. So we'll say export apply filter from dot slash apply filter. Okay, very good. Now, in the bug tracker component, this will automatically come as props to the component. So in the main index.js, we will take the apply filter also. We'll take the apply filter, and when the checkbox is checked, right? So we can say change is a on change. On change is equal to, when given the event object, call apply filter with event dot target dot checked. Right, event dot target dot check, so it will automatically apply. And now in the map state to props, in the map state to props, I will apply this filter only if it is checked. So we will say is comma, what is the name that we have given here, should filter, right? So should filter and should filter, then return this, otherwise return the bugs as it is. Just return the bugs as it is. Now go to the browser, wait for the application to load. The application is loaded, right? And let us do something. Let us expose the store to the window so that we will have we can verify this. So window of store equal to store. Okay, so that we can access it from the console. So now let us look at what is store.getState. This has should filter false, spinner data 0. Now click the checkbox. Now go here, should filter is true, right? Now click the checkbox again, go back, should filter is false. Very good. Now let us check if this is working. We'll have bug 1, add new, it is showing up, add new 2 and 3 and 4, right? 1 2 3 4, all of them are showing up. Now let us toggle this, I mean let us increment this 1 2 3 4. This is not changing, right? This is not changing. Now you apply filter, now this is changing. This is even number, I'm sorry, odd number, so this shows 1 out of 3. And you say up 2 and 4, 1 and 3, 2 and 4, 1 and 3, 2 and 4, 1 and 3. Now remove the checkbox, it displays both of them. Right? So see, the problem with the advantage of this implementation, whatever we are doing, the advantage is our application is literally broken into small pieces, right? And we assemble all of them together to make a complete application. So the advantage is it is very easily maintainable, but the disadvantage is connecting all the dots and finding out what need to do if you want to get a particular behavior can be a little tricky. And for that, right, what is very important, this diagram is important. What is a diagram? UI, action dispatcher, store, and then the reducer, right? And then the render app, and then the component getting rendered. So this flow, right, you have to always keep in mind this flow. If you keep in mind this flow, then everything becomes easier.
Just a quick question. With that connect, back in your connect, is that just going to grow and grow and grow as we add more logic here?
Yeah. The reason is, see, this filter as a see this particular functionality. When you talk about the filtering, right? This is, does it result in the state change? If it results in the state change, then you can use the reducer and modify the store state. But here, this doesn't result in a state change. We only want to change which bugs are displayed. That's all.
Right.
Right? So the right place for it to be, don't change the store state for this purpose. Instead, you implement it in the map state to props. Nothing wrong, because the logic in map state to props is all about what data you want to be passed to the component. Right? So if that involves some logic, if that involves some logic to extract the data, obviously that is a place to write.
Okay. And if I added,
sorry, go on,
I was just going to say, if I added another checkbox, say I had two checkboxes, one for positive and one for negative, odd and even numbers. I'm just looking at the size of this connect thing. Can you refactor this logic out and make it easier to read? We've only got one checkbox. We could have 10 checkboxes, that manipulate the presentation of this UI. If I start getting into that, if I done something wrong.
How do I say?
Just go back to that connect. Bring up the connect example on your screen.
Yep.
So we've got one filter, but say I had 5 filters that did different things. I'm going to have 5 more conditions in this connect, right? To manipulate that view. Is that just the way it's going to be, or is there like another React Redux kind of shorthand way of doing this?
So what you can do is you can refactor this into another JS file that will export a function. That function will take the store state and do all the manipulation and return what data matches all that particular criteria. So the maximum refactoring here that I can think of is wrap it and make it into another function.
Okay, and you can just have multiple functions in that connect. Okay,
correct.
Right.
So Pete, you were about to say something.
No, me just asked what I was going to ask. Thanks.
Okay.
Another question.
Sure.
How many? So we're breaking things down and we're getting a lot of dots to connect. I mean, does this suddenly, is there like a limit to how many dots we connect before it just becomes out of hand and we have to start thinking about doing things a different way, or is that just keep on adding dots until it gets bigger and bigger and bigger?
Where here?
Just throughout the whole. So I got Yeah, so I've got like 50 checkboxes for some bizarre reason. Am I just going to have to work out how to follow this flow all the way around and just hope I don't muck things up?
So here is a thing. Here is a thing. Okay, so let me tell you. Now you have all those 50 checkboxes. You say you have all the 50 checkboxes. Now these checkboxes, do they influence what data that you maintain in the store, or do they influence what data you display in the UI?
Bit of both. Say they do, some do some, and some do the other.
So in which case, some of them, anything that has to reflect, uh, reflect on the data that you maintain in the store, that has to go through the action and the reducer.
Mm-hmm.
And the checkboxes that will influence what data that you display will be accessed, will be processed through the map state to props.
Okay.
Makes sense, right? For example, let me take a simple example. We have the use case called sort. Did anyone implement it? I
What
told you
use
to
case was
sort the bugs.
that? No, I didn't get the sort
No,
bug
right?
going.
Okay. So now let us discuss. I don't think we'll have time, but let us discuss. So if you let's take the component here. So we have the bug sort component. So under the views, we have the bug sort component, right? So here, let's say I'm going to display ID, and this is ID, and name. This is name, and option value equal to is closed, and this is status, and option value equal to created at, and created. Okay, so we have all these drop down list boxes. Now let's go here. We have let's say we have the bug. So bug 1, bug 2, bug 3. Now if I, and let me toggle this. So I'll toggle this. Now if I select it by name, this has to be sorted by name. If I select status, it has to be sorted by status. If I select created, it has to be sorted based on when the bugs are created. And if I select the checkbox, it has to be sorted in descending order, not in ascending order. It has to be sorted in descending order, right? Very simple. Now, where will I implement this logic? Where will I implement this logic? So I can implement this logic in two different places. Number one, I can sort it in the action creator. I can perform the sort operation in the action creator, and then give the bugs to the reducer and say, hey boss, keep these bugs, right? Throw away what you already had and keep these bugs. So automatically, when it is rendered, they will be rendered in that particular sorted order. So the sort operation can be performed in the action creator. Number one. Number two, right? The sort operation can also be performed in the map state to props.
Right.
The sort operation can also be performed in the map state to props, right? So there are two places where I can perform the sort operation. Now, what is the right thing to do? It depends. Depending on what? Very simple. If the sort order, if the order in which you maintain the bugs, if the order in which you maintain the bugs, is it going to influence the business logic? Is it going to change how the application behaves because the order is changed? If that is the case, then the right thing to do is you implement it in the action creator so that it gets updated in the store. It gets updated in the store so that other parts of the application might want to access this sorted order of bugs. But that is not my requirement. My requirement is I only want to change how the bugs are displayed. I don't care how they are maintained internally in the store, how they are maintained, but I am interested only in changing how they are being displayed. If that is the case, then you use the action creator only to carry the two information. What is the information? What is the attribute by which you want to sort, and whether it has to be sorted in ascending order or descending order. That information you carry, keep it in the stored state, but use that to perform the actual sort in the map state to props.
Okay.
Right? So it is purely contextual. There is no right or wrong answer here. You can either do it here or you can do it here. Okay. Now,
Yep.
when will I decide to do what? Very simple. Classify. Try to classify the operation that you want to perform either as a command or as a query. If it is a command, it has to be in the action. If it is a query, it has to be in the map state to props. Simple. So the sort, is it only how you want to display, then have it in the map state to props? Is a sort, should the sort result in the state change of the application so that it will have an impact on other parts of the application? Then it has to be in the action creator.
Okay. Yep, that makes sense.
Yep. Very good. So this can be an excellent exercise. So what you can do, implement two versions, both the versions. So after the tomorrow, you can take this code, or today evening, take this code and implement both the versions. Sorting in the actions and as well as sorting in map state to props, implement in both the versions. You will know the pros and cons of both the approaches and when to use what.
Okay. Yep. I can do that.
All right.
Just a quick question. So you
Sure.
said we could implement sorting in the action creators, right? So is there any harm in doing that in the reducer itself, wherein the action could just pass on the sort order to the reducer and the reducer is taking care of it, or is it something
Um,
that's not recommended?
yes. See, the reducer should not have any application logic. The reducer's job should be simply keeping the store state synchronized. That's all. If something need to be added to the store state, it should do. If something need to be removed from the store state, it should do. It should be responsible only for synchronizing the store state. But no logic, no core application logic should be there in the reducer.
That makes sense.
Okay. Any other questions? Are we good? I hope this brought in some clarity in Redux. Good. So try this. This will be an excellent exercise. Try this. The sorting part. Try it later when time permits. Implement it in Action Creator, one version. Implement it in Map State to Props, another version, and see what you get. Okay. Now there is one minor problem here, right? Let's see who has the solution for this. So let me reload the page. Let me add 4 bugs. Okay. So bug 1 and bug 2 and bug 3 and bug 4. Okay. And then let me toggle 1 and 2. So if you look at the count says that 2 out of 4. So 4 total bugs and 2 closed bugs. No doubt it is working fine. But let me apply the filter. When I apply the filter, it shows the even bugs because 0 is considered as even. And you add 1, it shows the odd bugs, even bugs, odd bugs, even bugs. Fine. But look at the stats. Stats is displaying what? 1 out of 2. The question is it 1 out of 2 or is it 2 out of 4? What is the correct, what is the right data here? What should be, what could be the right data displayed here? Should it be 1 out of 2 because you are displaying only 2 bugs and out of which one is closed, or should we display 2 out of 4 because there are 4 bugs and out of the 4 bugs 2 bugs are closed? So what will be the right data to display?
There isn't really a right one. It's just a question of what it's meant to represent.
Right? Okay, very good. Now this is by default available. 1 out of 2 is by default available. But let's assume that the business doesn't want the count of this. The business wants the whole count. In the application, how many number of bugs are there and how many are closed. Now, even though we display only 2 bugs, we have to display 2 out of 4. Where will I write this logic?
In map state to props, right? Because it's what you're trying to display, no?
And what will I pass to map state to props?
I don't know. I'm still working on
that. You're right. Right? Now there is more logic involved in deciding what need to be displayed here. Right? There is more logic involved in deciding what need to be displayed here. So you know what I can do? This at this point of time, right? Only the main bug tracker component is a connected component. At this point of time, only the main bug tracker component is the connected component. But it doesn't mean that you always have to have only the main component as the connected component. You can have other components also as connected components. Okay. For example, let us take the bug stats. Don't expose the whole bugs. Import the connect from here. Connect from where React-Redux. React-Redux, and then here we will export default connect map state to props, and with this map dispatch to props and this. Okay, so here we will simply write the function. The function is when given the stored state, right, or bugs data as bugs, and then you can simply return an object where total is bugs.length, comma closed count is bugs.reduce of when results, comma bug, and when given this, you can say if the bug is closed, then plus result, otherwise return the result as it is, and 0. Right? What is wrong? Okay, so the semicolon is not needed. All right. Now here, what I will receive? I will receive the total and closed count. And I don't have to calculate the closed count here. Just display the closed count, and here display total. So the component need not even perform the logic of calculating the number of closed bugs. That will be performed by the connect the map state to props, and then we pass it to the component. And then in our main bug tracker, right? I don't have to pass the bugs. I simply call bug stats. That's all. The connect will automatically send the bugs to it. Now let's go to the browser and let's add a bug. We'll say bug 1, add new, bug 2, add new, bug 3, add new, bug 4, add new, and toggle 2 and 3, and you apply filter. This displays what? 2 out of 4, even though there are only 1 out of t, right? So nothing stops you from doing it. Your component can be connected component, right? Now here is a thing. Don't abuse this. Don't abuse this. So in your application, what you should do, we classify the components into two. One is what we call as a smart component. The other one is called as a dumb component or presentation component. We call it as a presentation component, right? So a smart component will receive data from Redux infrastructure, basically where we use the connect API, etc. A presentation component is used inside a smart component. So this is also called as a container component, right? So this will have the connect API plugged in, so it will have access to the whole stored state, and they can decide what they want to take from the stored state. Whereas presentation component, it will receive the data from the parent and display. It will receive the action dispatches from the parent and simply dispatch the actions, right? That is what they will do. These are not connected. Now in your application, you are supposed to have fewer smart components, as few as possible, fewer smart components, and as many presentation components as you need, right? But that doesn't mean that all your you should have only one or two smart components. It doesn't mean that. You can bypass that rule depending on your need, right? So here, like what we did, we converted the bug stats into a connected component. So the bug stats gained access to the whole store state, and it took whatever need to be done and took that particular data, processed it, and passed as props to the component, and we are displaying it. So don't overdo this. This can be used for bug item. This can be used for bug list. This can be used for bug sort. This can be used for everything. That's what I'm saying. So don't overdo it, don't underdo it. Find the right balance where you want to have it and then use it. Is that clear?
What's the disadvantage of having lots of smart components? Just more maintainability? Is that what you're getting at?
The thing is, you lose control. If you have a lot of smart components, right, you lose control because they will decide what data they want.
Okay.
Right? They will end up deciding what data they want, and then after some time, if you want to control what data that they are supposed to manipulate, you will have to touch all the smart components. Right? So simple example, let's take 0. So you have to deal with a lot of customers. Now you have a lot of developers in the organization. Now every developer can be, let's assume a scenario where every developer can be directly contacted by an end customer, right? And every customer will have its own change request, its own bug issues, etc. Now obviously we cannot take it on ad hoc basis. So one customer comes with one bug, another customer comes with a change request, and every developer cannot receive the bug report or the change request and then start implementing them. No, that will not work. So what is the solution? What do? We have a process in place. So we collect all the bug report, we collect all the change requests, we prioritize them, we understand the time availability, resource availability, all those things, and then someone, right, or the product manager or whoever it is, the architect, product manager, project manager, whoever it is, and they take a call. Okay, for this release, this many number of bug fixes is going to happen, this many number of critical change requests are going to be implemented, and then the developers take it from the project manager or product owner, and they go about implementing that, right? So here the project manager or the product owner is your smart component, each and every developer is your presentation component or dumb component, right? And if you directly let the end customer deal communicate to the developer and decide the schedule, then it is going to be only a mess. You cannot orchestrate it, you cannot prioritize it, it becomes very, very difficult, right? So the right balance is what is needed. That's what all I'm saying.
Okay.
Did I answer your question?
Yep.
Okay. Good. What else to discuss here? I think that's pretty much it. Okay, very good. So this is one very fundamental and important aspect of Redux, right? Many times we overlook map state to props and map dispatch to props, but a lot of presentation logic can be implemented in map state to props, and we can relieve the components. We can relieve the components from doing any processing and use them as true presentation components. And as I said, please implement the sort logic in both the approaches. One is in the action creators and as well as in the map state to props. And probably what you can do, you can also do it in the reducer as well, right? That is also another place where you can do and analyze the pros and cons of all these things. So you will decide where to use what. Okay, very good. Now, what is the next use case? The next use case is server communication, right? So this is a homework you implemented. Now persist the bugs in the server. Persist the bugs in the server. So how will I persist the bugs in the server? In order to persist the bugs in the server, we need a server, right? We need a server API that using which we can get the bugs. So where is the server? In our production application, we will typically have APIs built using Node.js or Python or Java or .NET Core or Ruby, right? So Golang, Scala, using any of these languages, you will create APIs that will serve data. But our focus here in this training is only front end. So we don't have to spend time building the backend APIs. So what is the solution? The solution is we have a node module called JSON server. Okay, go to npmjs.com and JSON-server, right? So this is basically a node module that gives you full fake REST API with zero coding. Okay, full fake REST API with zero coding. So basically what it does is if you give a JSON file containing some data, this server will serve the data from the data file as a RESTful endpoint. So a proper RESTful endpoint, right? So what you can do, you can add data, you can make a post request, you can make a get request, you can make a put request, you can make patch request, you can make options, you can make delete, right? So all sorts of RESTful calls you can make, and the server will respond. And the best part is all your changes will be persisted, right? The file will be updated with all the changes. The file will be updated with all the changes, right? And so this is at a very high level. But what you can do filtering, you can do slicing, you can do pagination, right? So you can perform all those operations as well. So this is a very, very interesting, very useful tool for development. For example, when you are building an application and the backend services are not ready, you don't have to stop building the front end part of the application because the backend services are not ready. So once the contract is created in terms of how the data is going to be shared between the backend APIs and the front end, once the contract is created, you can create a simple data file, a JSON file, and use that to serve use that in the JSON server API to expose the RESTful endpoints where the user can add data, modify data, delete data, etc., etc., etc. You can do it from your application, right? So what we will do, we will do one such thing here. How we will do it? So let us go to the application. Here we have the store.getState, right? So here is our data, and here is our bug data, right? Here is our bug data, and what I will do, I will stringify it. So JSON.stringify of store.getState, store.getState, and we will take this whole string. So copy this, paste it here. Toggle wrap. Now this I will call it as bugs. So this as an array and an object with ID, right? Name. I'll quickly do this, and is closed and created it, and then create one more object with ID, name is closed and created it, and that's enough. That's enough. Okay, that's it. So this is an object, and in this object we have an attribute called bugs, and the bugs has all this particular data. And now if you want, you can also have other sets of data as well. For example, you can also have projects. You can have projects, and the projects can have array, and the array can have ID is 1 and name. Project name is let's say payroll star, right? And similarly you can have one more project, and this can be 02 and name is accounting master, right? So we have this particular data. Now let me save this. Create a new folder, 06 data, and here let's say app data.json. Okay, so I'm creating it as a JSON file. Now let me create one more terminal window. I'm creating one more terminal window. I'm not disturbing the terminal window that we created for our application. I'm creating one more terminal window, and go to the folder that contains the file. Make sure you are in the folder that contains the file. So cd documents training 006 data. So if you look at here, I am in the folder that contains the file, and from here run the command npx json-server appdata.json. And unfortunately this server will also run on the same port number as this, okay, port number 3000. So this will also run on the same port number. So you can change the port number by using an option, a switch called -p, and in -p we can say whatever is the remaining port, the available port number. I'm going to say it is 3030. What is wrong? Malformed JSON file. Why? Bugs is an array.
Extra
Extra comma.
line 18.
Right. Thanks. Yep. Thank you. So there you go. Right. So what it did, it now picked up the file, parsed the file, understood that there are two entities. One is bugs, the other one is projects, and it exposes endpoints that says localhost colon 3030/bugs and localhost colon 3030/projects. Right. So now these endpoints are proper RESTful endpoints. So you can make GET request, POST request, patch request, delete request, option request, head request, all sorts of requests you can make. For example, I'll show you. So let's go here and say http://localhost colon 3030/bugs. So this will give you all the bugs, and say /projects. This will give you all the projects. And in the bugs, you say /1, it will give you bug with an ID. So one requirement here is that the entities that you save, right? This is the expectation from the JSON server module. So the entities that you save must have an ID attribute. Okay, so so if it has an ID attribute, then what you can do, you can even persist them. You can query by their ID. So /bug/1 /bug/2. So this gives you the bug with an ID 2. And then what if you make a request for a bug that does not exist? /3, it will say what? It is 404. Right? It is 404. Now, can I make post requests? Can I make put requests? Of course you can. So I'm going to use the Postman application. Take this, go to the Postman application, and clear all. Right? Now create a new request. Sorry. Yeah, I can do it right here. So create a new request and paste the URL. So http://localhost colon 3030/bugs, and then make a post request and go to the body and set the data type to raw and the type as JSON, application/JSON, and then paste this. And because we are going to make a post request, I'm going to set the ID as 0 and the bug is 3 and is closed is true. Are you with me? Right? So I'm doing all these things, and then I'll say send. When I send, you'll find that I got the response back with the status code as 201, and the response ID, bug ID is 3, with name is 3, is closed is true, etc. Now I sent it with ID as 0 and I received it as ID 3. Now is it happening only in the memory? No, it is actually persisted. See here, so this is the updated JSON file, and you will find that the file has bug 3. So all the requests that you are making, put request, patch request, delete request, options, head, get, post, all those requests, if the state is changing, then the state will also be persisted in the file system. So that way JSON server is a beautiful tool that can be used for prototyping and or creating a sample for your application, learning, training, etc., etc., etc. Okay, so what we will do, we will use this server, and we will, from our application, we will talk to this server, get the data, and then show to the user. Right? So that is what we will do after your lunch break. I'll check in the file, so you can take the file, and later I'll help you set it up, and then we will learn how to communicate to the server to get the data. Make sense? Very good. So break for your lunch. Be back by 1:30 your time. We'll continue. It'll
Cool.
be 6 o'clock for me, 6 a.m.
Breakfast.
No, breakfast is much later. Usually it is 8:30.
Okay.
I was actually looking forward to come visit New Zealand. Last year I had been to Wellington, and this time I was actually looking forward. But unfortunately, by the time this training requirement came, I had to visit Singapore for another training program. So I was unable to submit my passport for visa. And New Zealand visa takes some time, at least especially from India, it takes at least 3 weeks. So I could not give away my passport for visa. So uh, and I missed a wonderful opportunity to travel to New Zealand.
Yeah. And some sleep.
Yeah.
Not the
Right.
right time.
Oh, is it?
Yeah, who knows? You might, stay in a quarantine or something
Oh,
for
really?
a few more days. Yeah, not
Okay.
necessarily, but yeah.
Oh. So last time it was a very unique experience. Actually, I was able to get the flights only to Auckland, but I had to travel to Wellington. So I took a bus ride from Auckland to Wellington. Amazing ride it was. All right. So finish your
Okay.
lunch and come back. We'll continue the discussion. Bye.
Cool.